Some of you may or may not have ever hosted a game server before. Basically, we've had some extensive experience with running specifically Counter-Strike server for how long? A year?
It went about 7 months before they complained, so I would say
yeah.
So about 7 months before it became popular.
Yes.
No. We actually probably had about 3 months of popularity before TO was aboard. But at any time, feel free to ask any questions. Raise your hand, please. Give us feedback. Basically, obviously, about hosting game servers. System construction is probably one of the most important things when you're considering making a game server. Obviously, processor, RAM, hard drives, the operating system, and minimally decision is like a case. For a processor, we found with our experience that a 500 megahertz processor was plenty enough to run the system for the max number of users. Throughout the rest of the hardware that we're going to be talking about, you're going to notice a trend, which is that bigger is not always better. It's fast is what's key for having a good server. So like you see on the note up here, having a faster cache on your chip is probably, you're going to be better off than having a larger cache, no matter what chip it is. What chip were we running?
For the test box that we're talking about today, it's a Pentium 3 550 with a half meg of cache at core speed, of course. I believe that was what the Pentium 3s were all cool about. Anyway, we'll get into exactly why faster memory and faster caching appears to be more important than more memory and more cache available later on. But suffice it to say for now, like people who would like claim or try to push their popularity or say that their server is cool to play on because they have a faster CPU don't necessarily understand what the game server really wants, what the process really is asking for from the system in terms of system calls it makes, how actively it makes them, and what sizes of data it's moving around when it makes those calls.
You'll see a lot of different quote-unquote claims, just one sec, saying, hey, come play at our server because, we have dual P4s. Whoop-dee, dual P4s, not necessary at all for any kind of gaming.
Yeah. How many users did you have at any given time with 500 megahertz?
The max we ever had was probably 24. We didn't really want to push it beyond that just because of pipe limitations and whatnot. One sec. For the most part, the number of people that we had on average was between 10 and 18. We found 18 was actually a pretty optimal number for a number of people on good gameplay and whatnot.
Wouldn't, as like the dual processor thing, wouldn't a dual processor be practically useless because isn't something games are rather more like almost like single process rather than
even especially if you're talking about older games, the older games go back to not optimized for multi-threaded use and dual procs especially. So
Half-Life is multi-threaded. It is a single process.
It's one of few.
So if we were running a game server that, say, spawned a certain copy that listened to the proper, like if it was a TCP game and they attached a portion of the game code to a socket as a connection came in, if it process tasked and process queued across multiple processors, then you can get away with running it and gaining something from that in an operating system like FreeBSD that doesn't have fine-grained SMP and that can't move the kernel from proc to proc. And they have to basically keep one set of I/O controls running at all times. So the first processor more or less just schedules the second and third and the fourth. So if you had a multi-process oriented game, you may get something out of that. But on an OS that has finer-grained SMP support like Solaris or Linux, supposedly you do get gains of multiple processors on Half-Life, but not significant gains. Not that
The
would
most
say.
significant gains you're going to get is if you're running multiple servers, and then you'll see better performance that
Yeah,
way.
for example, if you had a gigabit link between 3 boxes and you had round-robin distribution of incoming connections to your game servers and kept all of them more or less evenly loaded, you could have incredible performance across that. States could be replicated between all of the game daemons on gigabit links almost effortlessly, and
If you
player
want, you can
communication.
separate the processes between the different processors, have one running on one and one on the other, have them more or less dedicated to each one, or whatnot, or, have them constantly switching,
Yep.
so. On to RAM. Obviously, the faster and more RAM you have, the better off you're going to be. What it says on here is that anywhere between 256 to 512 megs of RAM we found will run the same system, with 500 megahertz processor for the typical maxes of 24 to 32 users. As you head towards 32 users, you're definitely starting to push your limit. Like I said, faster access times are definitely going to help you out, especially when it comes to RAM, because we found that a lot of games like Half-Life are very interested in RAM and having it there. So DDR RAM is definitely a good option, and as just a note up there, it's actually extremely cheap because of the RAM prices dropping for the past couple of years.
I don't know anything about Counter-Strike or Half-Life or anything like that, so can you give me an idea of what the games are like and what kind of...
Sure. Half-Life is basically, it's a 3D shooter, and Counter-Strike and Day of Defeat, there's other things, those are modifications for the game. They basically rewrote some C code to overlap on the Half-Life engine, and it's usually just a group of users. Counter-Strike in particular is 2 teams, it's a terrorist team and a counter-terrorist team, and they have objectives. Either eliminate the whole team, or protect a bomb site, or bomb the site for the terrorists, or capture hostages, or kill them, that sort of thing.
Should I start bringing up some numbers? Do you have that for the slide?
No, I don't have any numbers in here, so go.
Okay.
Feel
As you talk, I'll just put this up.
that's fine.
What are the responsibilities of the game server?
The game server,
Doesn't
it
do any
handles
rendering.
all server to client data. It handles the connections, disconnections. It holds all the state data for locations of players. It holds all the textures and sounds, and that's all server-side stuff, so it's less hackable by client end.
Okay, so maps are on server side.
Yeah, they're server-side, but they also need to be on client side. What happens is the server says we're running this server, and it's got it in memory space on there, and then it has to load up on the client side.
Okay.
So in the case of Counter-Strike, almost all of the processing the game server in multiplayer games on the server rather than on clients.
Well, the biggest processing takes place usually on a map switch when it's loading all the new textures and that sort of thing. Otherwise, the processing is very minimal, and that's why we found that you only need like a 500 megahertz processor, because basically all it's doing is using the processor to send out the state data and maybe process objects in the game that change, that sort of thing. So a minimal processor usage, really. It's mostly the RAM holding all the textures and whatnot in memory.
And in the case of Counter-Strike, does the server try to keep a fully consistent internal state of the entire game and verify that all the data sets by the clients is consistent with that internal state?
Yes, there is acknowledgments, and that's what we're going to mention a little bit later about the protocol operations, or how it talks to the other players. There is an interval, probably about 3/4 of a second to a second, where you'll see larger packets come back from the server to the client. They're, of course, exchanging very small state packets, the 60 to 70 byte size UDP messages that the server and the client exchange the entire time the game is playing.
We'll also be talking about cheating later and how that works.
But as far as things that have been decided by the server, rulings on a shot you attempted on another player, that acknowledgement, and then the verification that the message that used into the server got flooded to other players is, of course, back to you in those larger, more interval packets. So it is being kept and verified from the server to the client's perspective.
that's to make sure that like someone doesn't hack clients and well, bogus, well.
Like falsifying their actual player state data to the
Yeah.
server?
Yeah, basically the player state data for my experience, which is roughly 2 years of playing the game, I never saw an actual single hack that actually was able to modify state data successfully.
One of the things to keep in mind about the game server and why Colin mentions the limits kind of stop at 24, between 32 and 24 players, the load kind of does an exponential thing like this after about 24 players.
Scales nicely up
it scales-
until about 18, and then it starts to make some large jumps.
But it'll make more sense if you look at it in terms of what the server has to keep on doing and what has to happen in the server's brain to make this stuff work. Imagine a big matrix of players, player numbers, for example. Player 1 sends a message to the server, inbound message. What has to happen? It has to be replicated to players 2, 3, and so on and so forth. And it has to be acknowledged from 2 and 3, and so on and so forth. They have to supply acknowledgments back to the server to say, yes, what you just did was heard by me. It didn't affect me, obviously, because I'm not dead yet. For example, you shot someone that missed. But in any case, imagine adding on additional rows of players. You have to then send messages to the server. The server then has to then receive your data and replicate it to 24 of the players, or 25 of the players, and accept acknowledgments from all of them to determine what you did, to basically figure out if what you did affected anything that they're doing. So it's more like an exponential load as you add 25 players from 24. You add one more receives human player data and additional data to be replicated out to all the other players. So it is it's kind of a damped exponential load to the higher player counts.
Does it use like individual UDP packets for like each individual thing, or does it batch UDP packets, or batch various things like multiple acknowledgements and events and such in one packet to reduce header overhead?
There is coalescing happening. When I was using TCP dump and various tools to capture stuff, flows from machines that were playing this game, the question was, does Half-Life coalesce data into larger packets to be sent at a slower interval? And the answer is yeah. There's a packet that contains, this is all binary formatted data, so looking at it is useless as far as the payloads go. But the packet stream seems to be interrupted occasionally, not interrupted, but at least interspersed within the normal 30 to 40 packets a second streamed to the clients are larger packets, about 110, 120 bytes in size. Those contain, from what I can gather, data that is more or less management of the game, keep alive frames, determining path delay, trying to find out if your machine's still there. More or less keep alive management frames, but also decisions on a hit or whatnot. Or changes to the level are propagated in those larger
What
frames
I
too.
was more asking was whether so it appears that it does not move like an event data go and just like individual just shots be made and movements go and have like each client like receiving like multiple events and such like happening for other things in one packet and sending out multiple acknowledgements in like one packet at the same time as sending its own event data. So it does send those individually, like the 30, 40 bit things as you explained, things rather just big block than blocking them together.
Think of it like data that you create when you shoot, when you change a weapon, or when you jump or run or move. That data you're sending to the server, about 30 to 40 packets a second of 60 byte content. The ending data is about 3 to 4 kilobytes per second per player. But there are larger packets that are also being seen in these streams that are the overhead management data, the overhead decision data of what just happened in the level. As far as acknowledgements, that's what's done on each client side. So one player is not acknowledging 24 other players worth of data for the 25th coming out. They're acknowledging the fact that the coalesced decisions from all the other players arriving to them has been received.
Okay.
So it's kind of like, this is not exactly a good representation, but as you add additional players, each player doesn't acknowledge the other player's data. They acknowledge the stream from the server to them containing the other player's data. The other player's data, rather. So.
Okay. Well, we got a
Go
shot
ahead.
here. So, onto hard drives. Obviously, the most optimal setup you can have for a game server is SCSI set up in a RAID 5 configuration. As you can see up here, with why we suggest RAID 5 is, in particular, Half-Life generates not one, but several log files, and if we're using that to generate statistics for the game, player kills, which is often, losing those log files can be critical. SCSI, obviously, very important here. That will give you the fast disk access you need in order to load those textures and sounds and all those things a lot faster.
The biggest thing is that any disk I/O from the Half-Life server is generally blocking. If it is waiting on return from a request to the file system, it may not send updates, it may not calculate decisions, it may not calculate physics from things that it received from player data. So you won't see the game hiccup, but decisions can hiccup. And it's not that it's critical, it's that it's worth keeping CPU usage to an absolute minimum when you're talking to hardware.
And of course, if you're using SCSI, you're going to be going through the RAID controller, and that will be doing all the interfacing to the drives. So,
Dale.
Did you actually look at how much I/O is actually going through to the disk?
There is less than.
I would think it would be next to nothing.
It is next to nothing, but it is blocking, and that's the problem.
yeah. And also, like we said, disk access does jump significantly when loading a new map, because you're looking at maps that range typically between 3 to 10 megabytes in size. Plus, you got to load all the textures for it, which is a lot. Plus, any extra sounds or anything like that. So that adds up quite quickly. And on machines that have slower disks, you will see map failures occasionally, very rarely, but you will see them. And other things just related to being slower disks, taking longer to load them, and of course players like it when their maps load quickly. So,
If I'm not mistaken from my experience of playing Counter-Strike, if you don't have a map on your machine, on your client, and you join a game in progress, it will load that map while the other people are playing.
yeah, we found they have a very inefficient way of downloading the map through the client. So usually, if you can, it's better to download it from a server if they have it up for download. But that's another issue. If one of the 24 or so clients does not have the map in question that's being played, that has to be downloaded from the server, so you're going to see disk access again there. More questions?
The texture you download, does it use compression or not?
I believe it's compressed. I haven't looked too much into how it's compressing the data, but I believe it is somewhat compressed. Not too much though, because that has to decompress and load, and so they don't know about it too much.
Is there an option to reject, like, new players that don't have the maps?
Basically, you can allow them to not download the maps, and basically it'll just drop them from the server then. For an operating system, we absolutely recommend using Flavor of Unix. What we had running on the computer in question was FreeBSD 4.2 running Linux 6.1 emulation. Ran beautifully, stable for many, many months. Yes, Maz?
I thought Linux was only up to like 2.4.
I got that number from Tony.
I'm sorry,
so-
Red Hat binaries and libs from 6.1. Clarification.
Oh, I understand now.
No.
I got that number from Tony.
Yes, thank you.
Plain Zam.
Yeah, like I don't think BSD emulates the kernel. I think it's
Two kicks in the balls, Tony.
thanks, dude. Thanks for being here.
So yeah, clarification there. But yes, we found it to run excellent. Excellent. Very, very stable.
Yep.
Case, basically, the two best options are probably either a rack mount or a tower case of some kind. Of course, you're going to want to have good fans, good ventilation on there, especially if you're running more disks and higher processor CPU, DDR RAM. You got to keep it all nice and cool. Those are the major concerns for cases. It's relatively self-explanatory. So, again, the main idea, my little joke at the bottom.
So a smiley face there?
Yes, it is. That was, uglyism emoticon of PowerPoint. So, fast I/O.
Emotional issues with this presentation?
Now, it's in reference to the preceding jokes.
Sure, okay.
Fast I/O, biggest issue with what we found to be with game servers. Better fast I/O you've got going, better server you're going to be running.
Right, with that, a couple more things I wanted to hit on for sure. Like, the reason fast I/O is important, we mentioned more cache is not as good as faster cache. More RAM is not as good as faster RAM. The reason for that is simple. If you're maintaining a large array in memory, the way compiled C code tends to do this doesn't create memory which is easily accessible within what would be considered a small range of memory that can be cached in what's called a lookup buffer. I'm sorry.
Well, I was gonna say, well, having more cache will increase your chance of having
Correct.
memory that you need in that lookup buffer, in
Correct.
turn increasing your speed.
Actually, it's not that data in the game or the state data in the game will persist in cache. It's that in cache, the lookup, basically each process when it's running on a kernel, a Unix kernel at least, will have a buffer which is maintaining its memory map into physical memory of the computer. For example, when a process goes and makes a system call to create a space to store memory or to store a value in memory somewhere, it is added to basically the TLB. The TLB is a name for a ephemeral buffer that is either on the chip CPU or held somewhere else, which basically says to the OS, when you request this value or this range of bytes, this is where it physically maps to. Every time a context switch occurs, when a process stops running and goes into wait or sleep, something else can be scheduled to the point where that TLB never has the data that the process just was requesting will persist very long. One of the things that takes the most time for a process to do is when it misses a TLB hit and can't find where its page has been mapped, the host kernel has to search the entire page list to find the data again. That's a much slower operation than if the TLB contained. Okay. That's a much slower operation than if the TLB contained the proper location of memory to go get the data from. So think of a big 24 or 24 player matrix of state data coming in from each player, internal state being counted to see if that update had been made back up to the player yet or not, and also other data that you have been stored historically, like player ranking, player stats, keeping track of overall delay for the game. All those operations of the HLDS run, that's the runtime name of it. That's the name of the runtime program inside of the Half-Life server. That process will allocate up to be upwards of 80 megabytes when you have 24 to 30 players in the machine. Within that process, though, if you have a large number of context shifts, what you'll find is the TLB never contains the data that process wants to go work with. So you waste more CPU and you waste more interrupts looking for the space in the blocks that have been allocated to that program to find the proper one where the data is stored. If the TLB persists long enough and doesn't get erased when context switch occurs, you make some serious gains. Talking with people who have done this before, standard kernels typically task switch at about 100 hertz. So every 10 milliseconds, a new process is being given an opportunity to run, and the other process is put in sleep. Even if it didn't elect to go to sleep, it is put in sleep. So every 10 milliseconds, the TLB is potentially being flushed. That doesn't sound very intuitive, obviously, if you have a big state table being kept, 80 megabytes, 70 megabytes of RAM, which you don't have quick translations to get to. Obviously a big problem in Half-Life. So if you want to keep player state, what we call a flood, basically when a state enters the Half-Life running daemon, the time it takes to get to the players and back to that server, not just to yourself, but from you to the server, out to players, and be acknowledged, that time grows large because if you have to sit there and look at every single byte you're writing to, manually looking through these block translation tables, you're wasting more time than if it was cached in the TLB directly. So the long and short of this is quite simple. If you're running Linux or BSD, you can tune your context switch time, crank it larger than 10 milliseconds. 50, maybe even 40 hertz is more appropriate than 100 hertz. The fewer times you task switch on a box that's primarily dedicated to just one task, you will see large gains in throughput. Not large gains in throughput, but large gains in the time to flood the state table. If the state table has to be updated and the memory it's hitting is not being cached, that's an additional 200 to 300 cycles per byte per block being read or written to. So if you don't have that problem occur, you essentially gain a lot more than if you had more memory or, say, a faster CPU. It's all about how fast you can get to the memory and update it quickly. Yes, Dale?
How much memory can you expect it to be using up when you say you have 32-page players?
At 24 players, it was over 70 megabytes.
Oh, crap.
But that's not purely state data for all the users. That's including map,
That is the
textures,
sounds.
That's everything.
But so you can see why.
It is kind of honking, and that's why you see you need a good balance between speed and amount, and that's why 256 to 512 we found was all right. as far as usage, then you have a lot of free RAM for any system processes that need to be run. Yet, if you're running some DDR 512 or 256, you're going to have the fast access you need to update within that 80 megs of data. Let's see.
Two options in FreeBSD to work with. HZ, it's stable, excuse me, as of like a month after a 4.4 release. The option for HZ showed up, so now you can manually adjust the counter used to basically allow context changes. And no memory hole. On current PCs that don't have any ISA devices that use DMA, if you don't have like an ISA network card that uses low IRQ and low DMA, you don't have to have this 15 to 16 megabyte memory hole reserved for ISA cards to do DMA activities through. On old 386s and 486s, it was common to have all these cards map their small amount of memory into a range between 15 and 16 megabytes. At the time, 16 megs was the biggest the architecture could accommodate, so that was why that was done. But now with PCs that have gig, 4 gig, 8 gig of RAM, that memory hole is still being looked at by the kernel as being potentially something that it can't walk all over because hardware is mapped its memory to application instead. So in the kernel, you can save about 4 or 5 instructions, at least in most OSs, by saying no memory hole. Do not expect anything to be there to write right through it. So that 15 to 60 megabyte ISA region is no longer need to be looked at specially or reserved anyway. So by those two options being added to the kernel, your scheduling drops significantly from where it used to be. You can't task switch at 100 hertz anymore. You task switch at 40 hertz. But that gives you a higher likelihood of the TLB, the translation cache, from having the memory already translated and basically cached that you need to get to, versus if you had a higher rate of schedule. And also the no memory hole will save you cycles when the CPU goes to store actual data in memory. Without having to check to see if that region is actually used by memory map devices or DMA devices, you can save significant amounts of CPU. Magnified by 24 players. If you're sending 3K a second from each player to the server, it has to incorporate upwards of 60 to maybe even 70 kilobytes a second of data in its own state table. Worry about whether or not those updates made it back out to all the other players, and secondly, do scoring in physics. So as you can imagine, when you do a systrace on HLDS run, there's almost 2,000 to 3,000 memory IOs per second. There's almost no disk IOs, about 3 or 4K a second of log data that rolls to the disk. Most of it gets cached in file system cache, and makes it really easy. You gotta wash it down with water. But as far as what the game wants, it wants fast memory. It wants to be able to persistently get to memory with low latency over anything else. So large CPU is as important as a CPU that can move more data, or a kernel that's more effective at scheduling how things run. So it's about all there is to basically having a fast enough host for half-life to be readable on a player machine. Did we answer your question, by the way?
One of the question was with external I/O, which is more specific, significant when you're dealing with speed, bandwidth, or latency?
That's a good question. As far as what Colin and I have observed with this game server we had running at my school, consistent lag is more important than outright low lag. It's handy if you have a connection that gives you full duplex Ethernet into an OC something. That's great. But
not everyone can,
But if the forwarding delay is random because of load, because of routing tables being injected into the thing, that won't be as good for the players as a T1 to an individual location that never experiences any other load and always has static routes to work with.
I was more talking about just I/O device, not talking about network.
As far as network cards, specific cards?
I was talking about like drives and also RAM. Those would probably be dealt with separately.
Okay, as far as main memory, some chipsets to avoid are LX and VX, even though they're touted as being compatible and stable. GX chipset by far has higher memory bandwidth than VX and LX. On the top of the class is RCC ServerWorks, which is just like the Intel GX chipset. If these names don't seem familiar to you, don't worry, I can give you some URLs later on to go research some more data about this stuff. But things like Dell PowerEdge, maybe Dell PowerEdge 300s, the 1U and 2U boxes, those generally have RCC ServerWorks chipsets. They do fancy things like console redirection out of serial line. You can do modem in dial directly. You even need a video card into things. very high featured devices, but those chipsets specifically are happy with working in banks of 2 or 3 SIMs at a crack, not SIMs, DIMMs rather. So fetches may actually happen across 3 pieces of memory, not just one. So that's one thing to definitely keep in mind. I haven't seen or worked on a box that has RAM bus. I'm not sure how that would play out. My guess is that the RAM bus memory might be a beneficial thing. Probably not worth the cost.
Actually, I'd say just the opposite. Rambus has the bad property of only keeping one chip active at a time
Oh,
on it
okay.
because it's so damn hot.
And Owen, I've also heard that RAM bus, while it has extremely high bandwidth, also has very high latency.
As long as you're doing
Yeah.
linear reads, it'll
Yeah.
have high
And this is anything but linear, though. That's the thing. The state table will look to the program flat and linear, but it may not end up that way in physical memory as far as how the kernel maps it. So it's more important to have outright low latency. I would think that currently DDR would be the easiest, cheapest, and the fastest out there.
Probably the best idea out there right now is DDR.
And the chipsets are getting better all the time.
Yeah. But in general, avoid LX, BX. Those are okay, but like not oriented towards absolute low latency. GX can guarantee, with performance counters enabled in the BSD kernel, guarantee latency to them. So, or guarantee randomly, average, generally lower latency. Put it that way.
Do you know if there's any advantage to a Xeon as far as memory bandwidth, or are you better off with just like a standard, Athlon or something like that?
To my knowledge, Xeons have larger cache pool on chip and at core speed. So in that case, yeah, it would probably be a more beneficial thing to get like a 500 megahertz Xeon than a 500 megahertz Pentium 3. But you're also going to be looking at more expensive
Getting the
chipsets.
speed and you're getting more cache there. So.
Wait, as for Intel chips, aren't Pentium 4s though aren't they almost worse because they have, if I recall correctly, they actually have lower size caches than like.
I don't know how Pentium 4 is on chip.
We haven't done a lot of research into the Pentium 4s when we were mostly doing this. We
Yeah,
were working with
because
Pentium
also-
3 and less.
yeah.
So.
So I also recall correctly that the Pentium 4 has a very high branch mispredict, extremely high due to their ridiculous increasing of the instruction pipeline length to allow them to ramp up their gigahertz for marketing purposes.
I wouldn't know how that would play out. My guess is that on normal platforms, you probably see performance increases related more to the clock speed and the frontside bus or memory access times than you would fancy predictions of things prefetch out of memory, for example. That's my gut feeling on that. I'm not sure, so I wouldn't be more inclined to say anything else on that. And that would be pretty much it, right?
I would like to talk briefly about kind of game server configuration stuff. Unfortunately, I was lazy, and as you see, that was the end of my PowerPoint presentation that I did earlier today. So I'm going to have to mostly wing it and make it very general. Basically, game server configuration you'll find is very standard across most games. You'll find that like Quake 3 has very similar server variables to Half-Life, which makes it easy to, configure both of the game servers without a whole lot of knowledge about either one. Security is also obviously a concern. I know a lot of people ask about it. They say, "Oh, you're running a game server. What kind of access can people have to not only the game server process and everything involved with that, but the actual system behind it?" For the most part, what we've found is there haven't been any direct hacks through Half-Life or Quake 3, that, to my knowledge, that have actually been able to penetrate into the system, except maybe with some maybe buffer overflows and whatnot that actually kick clients off and don't really harm the server at all.
But ideally, most good game servers won't use TCP anyway. So you'll have something which essentially has a process that just binds to a raw socket UDP to a certain port number. Yeah, there was no TCP overhead, so you can actually disable parts of it.
The game is entirely UDP, so.
Are there any games that use real-time transfer protocol?
Not to my knowledge, and none of them use reservation protocols either. So
It's
I don't
mostly
know why.
UDP or TCP, and most of the 3D shooters that you'll see are UDP based, because they don't want to deal A with the TCP overhead, and B, it's simple enough for them to send out massive quantities of UDP packets and not really care if a few miss. Yes.
In reality, I think it's going to be that if there are any exploits to come up, it's going to be something that's TCP implemented, and that if you set wacky header flags, let's make it wig out. Who knows? I mean, I seriously doubt the ability right now to like break UDP. I haven't seen any UDP specific exploits that overflow any kind of buffers, so in a long time. So because of that, you don't have to worry about too much. If you're just running minimal services like SSH in the game, people who say, oh, game servers are insecure as hell and we're not running one on our network anymore because of that, that's mostly phooey. As long as the host itself is cleanly secured, not cleanly secured, but cleanly configured, SSH version 2 only, RSA host keys on floppy, I don't see a problem.
Yeah, mostly how we ran the game server was we had a user with very minimal rights on the system, and we actually ran the process within a screen session. Screen, yes, has been known to be insecure in certain areas, but
So you mark 10 no suid and no exec and you're good.
yeah, making sure the rest of your system is all locked up, making sure you're updating with patches on screen, you should be okay with it. It's just convenient. A lot of the Linux binaries for the game are compatible with screen. They actually suggest using screen, so it just kind of makes them. It appeases the game in other senses. A lot of questions here. Maybe I should answer a couple. All right, we'll just start.
Hi. Can you run most of these game servers easily as root?
As what?
CHR.
Oh, chroot, yes.
That's my question too.
Yeah, I didn't chroot this, but jail and chroot do work if you recreate the environment that the process will need to get to all the libraries that are from the Linux compatibility.
You're gonna make sure you export the correct libraries.
Yeah, so if you just create the same environment you normally have as a normal user, then you'll be fine. There's nothing that will stop it from doing that.
Yeah.
However, ulimits that we clip file descriptors to a certain user, you want to watch out for that. 2,000 file descriptors at once is not uncommon for half-life to have. So be careful if you're using any ulimits inside of a chroot.
Did you have a question back there, Jeff? I thought I saw your hand go up. Did you have a question? No. Okay. You were kind of like, yeah, I don't want to hear it. Are you just gonna bash us?
No, I don't have any valid questions. I don't think.
Okay. Other questions about security, involve, the cheating within the game. There have been third-party programs, in particular for the Half-Life engine. There was a third-party program called Punkbuster, ran quite inefficiently. Supposedly, they're teaming up with the Valve team and eventually hope to have it integrated into the game. It worked moderately. It did prevent cheaters on some servers. Some servers, they just hacked the Punkbuster and got away with it. And it all depends on who the system administrator is and whatnot. Another concern is administration programs that have add-ons, and one in particular was AdminMod, which is very popular because it adds a lot of features that you don't get normally. It allows you to develop plugins for it that allow you to display text in colorful manners and make certain things glow or do whatever throughout the game. For the most part, what we found about security for such thing as AdminMod and whatnot is they actually, if you're running Unix, they have maybe, I think it might have been triple DES, encrypted passwords, which is alright. And the user login system with the passwords is all done by client executing a configuration which sends the parameters and sets things with the server. So as long as those aren't passed out and whatnot, and you lock down what is known as RCON, or remote console for the games, as long as you lock that down properly and trust the people that you give it to, there's not too much concern. And even if they do get it, the most they can do is take down your game server.
One thing, have you guys tried Paladin yet? Have you had any things with it? Because currently, I do some on the side work with basically a LAN place where we've been trying to find for anti-cheating, and we're currently running TSC. I don't know if you've had any experience with that. It's run by the people at Austin 2600. And we've had some success with it too. Have any of the sheets you've worked with work by guessing aimbot detection?
Some of them do that. Mostly, how the Punkbuster system worked was it had DLLs that it would checksums on the Half-Life DLLs, and it would also do a self-check on its own DLLs with checksums and make sure everything was copacetic. There were a couple workarounds, but most of them were resolved pretty quickly. I haven't particularly messed with either of those, so I don't know if I can help you out there. Other than that, I can throw some links up.
Yes, ma'am.
I have a question.
Yes.
Is it conceivable or possible to run a Half-Life server and have it not check the key so that, and not link up to the rest of the Half-Life network?
Not go talk to Juan.
Yeah, not to all the rest of the servers online so that you could use multiple copies of the same key?
There is a way to make it not automatically register with the master servers. It's part of the configuration. I didn't really mess with it too much because for the most part, if you don't have enough people that you know and you want people to come play, you have to register with the master servers so that people get the list when they update from them. Otherwise, they're going to have to know your IP or a domain that goes to that port.
What we could also do is just find the IPs that line round robin's authentication to, and then just like put an IPF or something, deny access to that. Just drop all the outgoing packets. It'll still accept connections from players even if it's not off on WAN yet. So that is one thing you can just do. Another thing that I've enjoyed doing a lot with this game is if you do have a machine that's like running some sort of kernel that you can compile in IP filter, or anything that can do NAT redirection. One way to keep the config style clean is because you do have to hard reference an IP address to listen to. One thing you can get away with is binding it to this 127.0.0.1 or some sort of loopback that you keep on your machine active at all times, and then do simple NAT redirection from the outside world from whatever interface you happen to have. So for dial-up, that could be a great thing. If you have your IP changing a lot, or if you're on ISDN or some DHCP service through your ISP, if your IP stack changes a lot and you don't want to use some DNS updater, bind your game server to 127.0.0.1 and port map, was it 21.571, whatever that UDP port is?
25.0.15.
27.05.
Yeah, basically if you map that range 27,000 something to 127.0.0.1 where your game server is living, the IP stack will never change as far as the game server cares. The outside IP stack can change, but as long as the NAT redirection rules always say anything on this interface gets forwarded to 127.0.0.1, your config never changes, which is a cool thing. A lot of admin-mons and whatnot don't want to see your IP stack ever changing on that interface. So one trick you can do. So that's it.
These are basically the main 3 links from here. You can pretty much find a ton of other websites linked off of them. Counterstrike.net is the main site for the Counter-Strike modification for Half-Life. From there, they have a lot of websites that they host within their own network, and they also link to a lot of other gaming sites and whatnot. Day of Defeat mod.com, I believe, is one of the newer ones I've been playing. It's interesting. It's World War II Nazis and Allies. Also mod for Half-Life. And then punkbuster.com, which is the website for the anti-cheat software. From those 3, you can find links to a lot of other sites. I would give you a link to the site that I've been working on for some time, but those are down due to server and bandwidth circumstances. So
Mostly charters circumstances.
yeah, we can blame Charter. Bastards blocking port 80. Anyone.
Charter has been so blamed.
Yes, N25 and N21, they must be accused of all.
Do they block 113?
Don't know, I only know about those 3.
They don't block high ports. Game servers still work.
Yeah, game servers still work, but
They think that life happens in TCP below 1024, so be it. Whatever.
some redirection to port 8080 can work occasionally, but depending on who, what, where, when, why. I think they also block 22 SSH, don't they?
No, they don't.
No?
I get to my box.
I thought Anyway, any other questions, comments, concerns, jokes, harassments?
We're gonna go out and run a server now. Why not?
Okay, you will suck then.
Already got one.